ICAR IARI New Delhi. He has secured ICAR ZRF SRF fellowship during master and doctoral degree program. He has cleared NET exam conducted by ASRB New Delhi, life member of different professional societies. His research interests include the solar energy conversion system, design and development of fish processing equipment and machinery, encapsulation of functional food ingredients. He has authored 15 research publications in peer-reviewed national and international journals, and also obtained 2 design registration, 1 copyright, filed 1 patent, and 2 design registration. He has also received Kerala State Energy Conservation Commendation Certificate. Likewise, he has also received other awards like ANERT, then AFST award from the Low Cost Technology Award from AFST. So now I request Dr. S. Morali for his next step. Yes, sir.
Good morning, Anandal. Hope I am audible. Am I audible, sir?
Yeah, you are audible. You can make a slideshow, PowerPoint, full screen as slideshow.
Yeah.
Okay. Yeah. Fine.
So first of all, thank you for giving this opportunity to deliver the invited talk on renewable energy, especially for drying of food products. So for next 25 to 30 minutes, I will be talking about the solar energy for drying of agricultural produce. So the outline of the presentation is like that. You will have some fundamentals of drying. Thereafter, what is solar drying of some food products. Then what we are basically working on the fish drying. So fish drying, then different type of dryers developed by CAFT. Then finally, how the dryers reaching the end people, the clients, through some entrepreneurship development. So that that thing will come in the end. So to start with, first of all, what is drying? These things I am not going into deep. So everybody is knowing this. It's not a new technique. So just to start with, I'm just giving some introduction. So it is basically a removal of moisture by means of evaporation. So there it is simultaneous heat and mass transfer occurs. So we are trying to reduce the moisture content. Thus, you are trying to reduce the growth of microbes, enzymatic actions, and other chemical reactions. So what we will do when we do the drying, we will get to know the moisture content. N moisture content will be low moisture. In turn, that will help us in storing the product for longer time. There is extended shelf life. You may be end up in lower storage space, reduced packaging requirements, handling requirements. Then mainly we will be able to give the product during off season. In addition, we will get a value added, diversified product that is meeting some of the consumers' demand. For example, if you say in the fish, some people like to have the dried fish, not the fresh one. So it is like a consumer's demand. One diversified product we can give through drying process. So what are the factors are affecting? You have the product parameters. You have the dryer properties, shape, size, thickness, composition, moisture content, surface area. When it says dryers, you see the type of dryer, design features, temperature, relative humidity, velocity. What is the drying time? What is the flow rate? What is the weather conditions when we say solar dryer? So these are all the factors are affecting. Then we have the relationship between moisture and the RH. You have the food product. There is an unbound moisture and bound moisture. Bound moisture is just like a free water, whereas bound moisture is attached with the food particles, whereas unbound moisture is a free moisture. So when we remove the unbound moisture and part of the bound moisture, we will end up in the equilibrium moisture that is based on the given drying conditions. What is the temperature, RH, we are giving accordingly, we will end up in the one particular EMC. So then there is a relationship between drying rate and the moisture content. You will see that there is a concentrated drying, falling rate drying. There are 2 types of falling rate drying period. In concentrated drying, it is not dependent upon the product, whereas falling rate drying period, it is dependent upon the product. In concentrated drying, the temperature of drying occurs at the wet bulb temperature. It's not basically the dry bulb temperature what we see. It is occurring at the wet bulb temperature. The water carrying capacity of the air will be met by the product. Whereas in the falling rate drying period, there are 2 ways. One is first falling rate, you have the unsaturated surface drying. It does not have sufficient moisture to give up. The second process is the diffusion process. The moisture has to come out from in to out. So that's how these 2 drying rate periods are there. Then we will come to solar drying. See, basically another 20 minutes I'll be talking about solar dryer and the solar drying process. This is basically has some advantages over the other drying methods. First of all, it is environment friendly and economically viable. But in solar drying, basically what we will do, there will be a simple structure. Okay, we will make a structure in which we try to enhance the effect of solar radiation as well as natural flow of the wind. By doing so, we will be able to get higher temperature, lower RH, and improved drying rate and lower final moisture content. And also, finally, we will be getting the lesser time for drying, complete drying of the product. So, what are the essential parts of the dryer? You can see it in the figure also. There will be a drying chamber. There will be a thermal collector, solar thermal collector, maybe air collector or a water collector. There will be an air flow system. You should have an inlet and outlet. Then there are different types of solar dryers. One is direct method, indirect method, mixed, hybrid, and the different researchers have classified in a different way. So in the direct method, you will see that the product is kept just below your glass cover. When we say indirect, you can see the figure on the right side. When we say indirect, there will be a glass cover down. The product won't be kept. Product will be kept separately in the drying chamber. When we say mixed, you have the both. You will be keeping the material under the glass cover as well as in the chamber. When we say hybrid, you will be including a backup system. Any auxiliary heating source will be included. So one of the classification from Lingayat et al. 2021, they have done the classification based on whether it is a natural convection, forced convection. Then it is based on whether sensible heat or latent heat we are using. Again, whether it is a direct, indirect, or mixed or a hybrid. Again, direct, that means you are directly exposing the product under the glass cover. So whether it is a cabin based or a greenhouse type. Again, if it is a greenhouse based, then what is the type of flooring we are using? Whether it's a concrete floor or your black painted or it's a sheet or a sand floor. Then it is a type of glazing material. Basically, when we go for low cost dryers, you will see that polythene sheets are used. UV stabilized polythene sheets are used for low cost solar greenhouse dryers. Also, polycarbonate sheet is used. Fiberglass is used. So based on that also we can classify. Then there is a structure, whether it is a single roof, double slope roof, it is a parabolic shape or tunnel shape, accordingly also it can be classified. Then whether you have a north wall reflectors, so that to enhance the solar radiation inside so that we can get maximum heat, or you are not using the north wall reflectors. Based on that also we can classify. When we say in the indirect dryers, you have a solar collector based dryers that I will be discussing in detail in subsequent slides. Then there are thermal storage systems. Some of the materials will be kept inside the glass cover so that that particular material will gain the heat during the sunshine hours and it will release during the off sunshine hours. Say you wanted to dry the material in the night time or you wanted to do it in the rainy season or cloudy day, these things can be taken up. Also, there is a solar water heater based air water heat exchanger that also I will be discussing in subsequent slides. Again, whether it is based on water or air, that can be again classified into two things. Whether you are using a non-concentrating collectors or you are using a concentrating collectors. If you are using a non-concentrating collectors, there are flat plate collectors, vacuum tube collectors, CPC, compound parabolic collectors. When we say concentrating type, you can see parabolic trough collectors, parabolic disk reflectors, linear Fresnel reflectors. So that way also it can be classified. When it comes to mixed mode, you will see that there will be a cabinet and solar air collector as well. Or you will see that there will be a greenhouse dryer in front of that to improve the preheating. Before letting the air go inside the dryer, you will have a solar air collectors. So the air will be heated up to say 40 to 45 degrees Celsius. Then it will be going inside the drying chamber. Then it will get further heated up to the required temperature. So that way also we can classify. When we say hybrid, there are photovoltaic thermal systems. This is a cogeneration system. It is a mix-up of photovoltaic panel and the solar thermal technology. As Madam was telling in the previous lecture, that when the temperature is more, the efficiency is coming down. You see the panel temperature goes 60 degrees Celsius, 65 degrees Celsius. The literature suggests that when the temperature is increasing every 1 degree, your efficiency, that is electrical efficiency, is down by 0.45%. 0.45%. That means when the temperature is more, your efficiency is down. On an average, we used to get about 12 to 14% PV efficiency normally. But in the hybrid system, what we will do, we will attach a solar collector in the bottom, just below the PVT collector. So it can be cooled through air cooling or water cooling, or we can also use nanofluid cooling. This also we are working at CAFT. We have developed a hybrid photovoltaic system. Then we wanted to use the system for drying process. Say for any classified dryers, in the left-hand side, for any type of dryer, this system can be used. So the small energy requirements for like running a fan, blower, or small lighting can be done through this system. Similarly, the energy, the water or the nanofluid what we are using, it will act as a sensible heat storage medium. So when the temperature is more, during peak sunshine hours, the temperature of the material will rise to a particular degree Celsius. Then during the off season or off sunshine hours, it will start releasing it. So like that we can use it. Then second one is thermal storage, as I already discussed. Then you can have a biomass assisted system, or you can have a LPG assisted system, or it can be an electrical assisted system. One by one I will be discussing in subsequent slides. Then you see Fadoli et al. 2010, they have given the common agricultural products and what would be the initial and final moisture content. What is the maximum allowable temperature? And also how long drying takes place. This is based on solar drying. The maximum allowable temperature is given, initial, final is given, how long it takes also they have given. You can see the figure in the right side. There are different types of products. All the agricultural materials can be dried in the agricultural products. Then I am going to the main topic of this presentation, that is dried fish. So say about 17 to 20% of the total catch of the fish in India is dried for export and local consumption. Then whenever there is a excess catch or there is a low value fish, when we freshly sell it, you won't get the that much price, or you see that the product will spoil very early. So during these type of products can be dried. So that is basically dried. Then there was a study in the Southeast Coast Harbor. They have found around 25 species is dried for the dry fish production. And you can see about 2,000 to 4,800 tons dry fish production is happening in the Southeast Coast. See, these dried marine fishes are transported to the inland areas for domestic consumption. And there is a report, this dry fish contributes about 7% of the total fish export. And also, APIDA in 2016 in its reports has given that this dried fish with MAP, modified atmospheric packaging, properly packed and given, this dry fish contribution to the total fish export can be increased to 25%. And I see that there is a figure in the right side that this is the Jagi Road dry fish market in Assam. That is the largest dry fish market in the Asia. You see how the fishes are dried and kept and how it is sold. So from India, Bangladesh is a net importing country. If we say in the wet weight basis, they are importing about 2 lakh tons per annum. So what is the importance of dried fish? It is a cheap source of nutrition. When we dried it, it can be available all over the year. Then it is resilience against the perishability concerns because you are preserving it. Then price fluctuations also can be reduced. Then it is a source of rural livelihood and income. Then during the pandemic and lockdown also, this dried fish has supported the fish consumers. When the lockdowns and pandemic, the present situation, the fisher folks are not going into the sea. So the dried fish can support during these times. Then how traditionally the fishes are dried in India. For that matter, in underdeveloped countries and the developing countries, the traditional method is open air sun drying. You can see the right side figure that is in the Goa coast, and the second one is in the Bombay coast. The first one is spread in the just beach. The second one is hanged in the wooden frames. The bottom one what you are seeing is called a Bombay duck. There is a fish dried and sold in the name of sticks. So you see the when we do traditionally how they are doing is directly exposed to the incident solar radiation and the natural wind, because the energy is free, renewable, abundant, and this type of method is cheap. You are not incurring any cost. Then you see the product is not good. It is inferior quality because it is dependent upon the weather conditions. Also, it is vulnerable to the dust, insects, pest, infestations of microbes. Then there is a study says that at least 30 to 40% of total dry fish production is lost during the open sun drying. When we are doing this type of drying, 30 to 40% of fishes are lost. So keeping these things in mind, different researchers has developed different dryers for especially drying marine products, and they have got the good results. So now I am going to talk about what is our CAFT initiative, what type of dryers we have developed. Then I will be subsequently giving the results. Out of that, what is the results we are getting? I will also go into details of how the dryer works. Then what is the energy efficiency we are getting through that? So first you are seeing the solar dryer with electrical backup. There is a 20 kg dryer. This is a flat plate air collector. You can see it from the top. This region, this is the solar flat plate air collector. This is the drying chamber. Then there is a blower here. So during the sunshine hours, the air will go inside, get heated up. Then through the blower, it will be circulated inside the drying chamber. We have also given up with a backup heat source to run during off sunshine hours. You have a control panel. So you can set all the temperature, whatever required temperature can be set. Similarly, we have a 40 kg dryer working on the same principle. There is a flat plate air collector, blower, drying chamber, then heating coil. Next is solar LPG hybrid dryer. In this, we are not using the air collectors, rather we are using the water collector. This is flat plate water collector, what you are seeing in the top. Here, we are using the sensible heat storage system. Thermal energy storage system also we can say it. Here you see there is a tank, insulated tank, in which the water will be stored during the starting of the dryer. That always, once we filled it, we no need to refill it. We can also have a sub tank in the top so that whenever any leakage is there, it can come and close it. So what happens once we start the dryer, this water from the tank, that is cold water, about 25 degrees Celsius, will be circulated through a pump to the collector. Once it is circulated, it will get heated up. Then the heated water will come and store in the same insulated tank. So this tank will act as a thermocline system. You will see that the top is hot water, bottom will be a cold water, because due to density difference, the hot water will store in the top, cold water will be in the bottom. So again, this heated water will come from the top. That will be sent to a heat exchanger that is placed inside the drying chamber. You can see this is a heat exchanger placed inside the dryer. So the hot water will go to the heat exchanger 1, then it will go to the heat exchanger 2, and then it will come back to the same tank that is in the bottom side. Why? Because when it is going inside the heat exchanger, it is releasing its heat. Upon releasing its heat, it will be cold. So obviously it will come and connect in the bottom side. Again, see, if it is a rainy season or a cloudy season, or you are trying to do it in the night time, so you may not have any control over the solar system. You will not get heated up. So what we have done it, we have kept a LPG backup system. You can see the figure here. Also, you see this tank. So through the LPG system, we have a burner here. When it is connected, and one more thing, this total system is automated. When we switch it on, all the things are automated. We no need to switch on the LPG. Based on the temperature, it will automatically on off. That also I will tell you. See now, suppose it is a rainy season or off sunshine hour, this cold water will be taken up by this pump and it will be heated up by the LPG system. Then this heated water will come and store in the top. So again, this top, from top only this water is taken to the heat exchanger. So here we are trying to maintain to about 80 to 90 degrees Celsius in the top temperature. Water temperature will be maintained about 80 to 90 degrees Celsius. Then when it is going inside, it can give about 20 to 30 degrees Celsius difference. It will go away. So that means in the drying chamber, we will get it about 60 degrees Celsius. So 55 to 60, that range we will get it. Then this water will come as about 30, 35 to 40 degrees Celsius. Again, store it in the bottom. Now, there is a case, if the cloudy cover comes in between, this water will not get heated up. So we have a differential system, solar thermal differential controller. So what happens? There is a temperature sensor in the top and there is a sensor in the bottom. It will check always the temperature difference between the tank bottom and the collector outlet. If you say we can set it. All those temperature requirements we can set. Suppose I am fitting about 10 degrees Celsius. So the temperature will be checked. If there is a difference of 10 degrees Celsius only, this pump will run and the water will come. Otherwise, what happens? It will continuously run. Then all the water will get mixed up. We may not have the thermocline system. Then here cold water will go inside and drying will not occur. So for that reason only, we have kept 2 sensors to regulate the pump. This is called a solar pump connecting between bottom tank and the collector outlet. Then we also kept one more sensor to maintain the top temperature. See, this LPG system will see what is the top temperature. If suppose it is only 70 and I have set it to 90, this LPG also will work simultaneously. Take the cold water, heat it and put it in the top. Similarly, if the temperature of the drying chamber is going more than 60 or 55, whatever we are setting, there is a temperature sensor here. It will sense what is the temperature inside the drying chamber. Accordingly, if the temperature is attained, this sensor will give a signal so that this pump will be cut off. So with the sensors, we are trying to control all the pumping system. So it is totally automated. We have about 36 trays inside. So each tray we will be putting the fishes in a thin layer. Then we are getting dried. And you see that the operating cost of this dryer is coming about 2 rupees only. 2 rupees 20 paise it is coming. It is less costing compared to other CAFT dryers. And one more thing, this blower also will automatically run. This blower will take the cold air from outside. It will go to the heat exchanger. When it is moving across the heat exchanger, the temperature of the air will rise. Then it will go up. Then there is a fan here. So it will circulate towards this direction to this heat exchanger. Again, because this fan is kept inside, it is creating slight vacuum. So this hot air will come here. It will mix with the cold air. So it will form a anti-clockwise circulation inside the drying chamber. We have an exhaust in the back. So this also we have automated with the RH sensor. Whenever the RH is more than 60, 65, we have said that this exhaust will open and the moisture air will be thrown out. So this is how this drying system works. The results I will be showing in the subsequent slides. We also developed a solar tunnel dryer. This is basically a polythene sheet. This is not a very new technology. However, we are trying to customize for the benefit of the fisher folks. The ultimate users, they always come here and ask for low-cost technology. They don't want a hi-fi technology, so they can afford it. This dryer will cost about 70,000 rupees. So you see the UV stabilized transparent polythene sheet is used for roof, and you see the black observer sheet for the floor. Then we have got the CPVC pipes only. If there is a permanent structure is repaired, that also we are capable of doing that. We are doing it already. There are 3 fans kept for inlet and outlet. You have the trays inside. You can see the figure. You can place the material and we can get it dried. And also we have connected this with PV panels. So we does not require separate energy. There will be a panel nearby. Through that the fans will be running, and we have not given backup, heat backup not given. So slightly the drying time will be more, and it is for affordable bulk dryer. Say it is 1.5 lakhs, we can dry about 50 kg of fish. Whereas when we go for camera type of dryers, same 1.5 lakhs, we cannot dry more than 20 kg. Then these are all the experimental results. We have conducted a study with Indian mackerel. That is salted one. You see at 55 degrees Celsius temperature with the RH of 47 to 60%, with the air velocity of 0.8. We end up drying the material to 31% and 30%. You may be asking this question, why the moisture content is more? It is 30. See, it is salted one. So when the salted one, as per our standards, BA standards as well as international standards, if it is salted, even the moisture content on the material can be as high as 40% on wet basis. 40, even 45% it can be based on the requirement. So when we dried it with solar hybrid dryer and the open sun drying, we found that within 8 hours, we can dry it in our hybrid dryers, whereas in the open sun drying, it is taking about 32 hours. Why? This is because you are trying to maintain the optimum temperature, that is drying conditions, with the help of backup heating systems. We are achieving that. The drying rate also higher. Then you see here, about 78% of the drying energy requirement has been supplied by the solar air collector. This is a 20 kg dryer, solar air based collector. You see about 78% of energy has been supplied through solar system. And you can see that this drying efficiency of 23.81% was observed for the salted Indian mackerel drying under the solar electrical hybrid dryer. Then we have also conducted another study in the LPG dryer. So the system has a flat plate water collector, thermal energy storage system, then LPG backup. You see the temperature was attained in the maximum of 73 degrees Celsius with the help of collector alone, the flat plate water collector alone. Then if required, we can go for LPG backup. Then we have dried this material to 15% with the wet basis, and within 6 hours we can do this. Then similarly, you can see here the collector efficiency is about 42%, 37% is the drying efficiency. You can also see here about 73%, 74% of energy was applied through solar system, and the LPG supplied the remaining 26%. I also have a comparison chart I will show you. Then we also done a quality analysis. You can see the proximate and biochemical analysis of the dried shrimps were carried out. Then we have found that it's not significantly affected by the drying process. It is microbiologically also safe. Also, we have done this shrinkage rate, rehydration ratio, color attribute, everything is within the limit, and the product is good quality, hygienic, uniformly dried. Then we have also done a energy analysis. You can see it here. See solar electrical dryer 20 kg, 40 kg, 60 kg, 250 kg, 50 kg tunnel dryer. The dryer costing we have given. Operational cost is about 3 rupees, and your drying time is 6 to 10 hours. Manpower required is only 1. You see, if it is operated in a hybrid mode with solar and electrical, you end up in 1795 units per annum, 1 year, about 240 days of operational days. Whereas if you are only doing with electrical, you will end up in about 4,500 units of electricity. You see for same 40 kg dryer, you see for LPG 60 kg dryer, how much difference is there in terms of energy? About 40 to 50% difference is there in the energy consumption. And then when it comes to tunnel dryer, we have not given backup system. This actually only maintenance charges are there, no operational charges. Drying time is, it will take about 1.5 to 2 days, and the labor also 2 people are required. Then see, we also have done a system to get the details of drying. See, most of the time when we do the experiment, we don't know what is the temperature of drying, what is the temperature in different zones. We don't know the temperature profiling inside the drying chamber. We don't know what is the RH. So if you wanted to know, we have to open it and check it, or we can have a data logger from outside, we can give it. However, when we are giving to the ultimate user, the client, he may not be expert. So he wanted to know what is happening inside the dryer. So what is, how much drying happened, how much moisture has been removed, when drying will complete, all those details. So we have developed a system with the sensors, temperature, RH. Then there will be a load sensor, and we have assumed some assumptions. Based on that, there is a Arduino board, there is a load sensor, and you have a GSM module. With this, we will be able to get the SMS. We have to feed your mobile number. Upon feeding, you will get the item is kept for drying initially when we are keeping it. Then we can set the time interval at what time you have to get the message. Maybe after 15 minutes, 30 minutes, 45 minutes, or after half of the drying is over, or it is completely dried. So all the details, we can get it through mobile. This we have actually got the copyright for the algorithm what we written in this. So this system we have not yet commercialized, but we have already experimented, and we also wanted to control the switch of the dryer itself when the drying is over. That we are presently working on it. So this is about the automatic information system for the dryer users. Then overall, what are the advantages? We have different dryers suiting different requirements. Energy efficiency, you can see about 42 to 59% less energy required for the solar system. It is renewable, no emission, no fossil fuels are used because we are using renewable energy. It can be easily installed and can be operated. You see that operational cost is very less. Construction also. If you take 250 kg dryer, it is coming less than 14 lakhs. The drying time per batch also 6 to 8 hours. If it is tunnel, it will be a little bit higher. Labor requirement also considerably reduced because you are not going to turn it. Once you put it inside in a single layer, thin layer, then we are not going inside and then we are shuffling it, all those things. So the lab requirement is very less, then improved self-life, value addition, and it can be finally used by the any individual small-scale industries, fishermen or aquaculture farm. Then which are the places we have installed this dryer? You can see this is a solar LPG dryer, 250 kg capacity. We have installed this at ICR Research Complex for Northeastern region at Impal. This is a professional commercial model. All parts you can see, these are the trays, SS trays, 304 trays. So then we also installed one more dryer of same capacity, 250 kg, Alapla, Kerala. See, this is also same principle, LPG system. But instead of one LPG, here we will be having 3 numbers. Then burner also will be 4 or 5. According to the requirement, it can run. Based on the temperature sensor, it will run required numbers. Then we also installed a solar electrical dryer at Directorate of Fisheries, Manipur, 100 kg solar electrical dryer, working based on flat plate air collector. Then we also installed one commercial model hybrid solar fish dryer with LPG backup at ICR Siva, Bhubaneswar. This is also working good there. Then now recently there is a walk-in type solar tunnel dryer. I already shown you the temporary model. This is a permanent structure what we are doing with polycarbonate sheet of thickness 6 mm with the GA purlin. It will be a permanent structure. Then Kadapa tiles for the bottom. So this with the World Fish project, we are giving 10 number of these dryers to Odisha coast. This has been already installed. Due to cyclone, we have also removed it now. So it can be installed, and if you want also during any exigencies, it can be taken out. So the bottom structure, this plain concrete and the Kadapa tiles will be there. This top portion can be taken out if required. Then through our ITME ABA section, we have empaneled manufacturing agencies for fabricating our dryer, supplying to anywhere in the world, including India, anywhere they can supply. You see that for last few years, we have supplied more than 30 dryers. We have supplied to Andhra, Karnataka, we have supplied to Northeast, Odisha also we are doing. We have different capacities. And as of now, for last few years, our installed capacity is about 1,400 kg dryer has been installed. Then I was talking about the entrepreneurship development. So what we used to do is that we basically conduct the drying trainees. About 2 to 3 days, solar drying trainings will be conducted at CAFT. The interested people will come there and get trained. Upon getting trained, they will register with our ABA, ITME section, and they will be called incubatee. We will enroll them for 6 months. So during these 6 months, they will bring their produce. It can be replicated for any products. For fish, they used to bring it and dry it in our campus. So this facility is given for 6 months. Upon drying, they get to know the technology. They will do the test marketing. They see that if this technology is working well and good, then they will finally come to us and take the dryer with the help of the empaneled agencies. What you are seeing in this slide is, you see some of the installations at Kerala. It is installed in the rooftop, about 20 kg solar electrical dryer. There is a 40 kg installation here. This is also in Kerala. Then you see one dry fish shop also with the help of CAFT guidance, one of the young entrepreneur developed. You see all the fishes are dried and kept in just like a bakery. It's like a nuts, they have been kept. Anybody goes there, they will get tempted to purchase different items. So it was one interesting initiative by one of our incubatee. Then you see these are all the products that are available in the market now. With the help of CAFT, with using our CAFT technologies, especially solar dryers, they have brought out these many numbers of brands for dry fish, and they are in the local, in the Kerala level, and some of the people are working throughout India also. Some are trying to export also. So you see the different brands. These are our incubatees. You can see this. Thank you.
Thank you very much, sir, for your nice presentation, briefing about the different dryers and technology which you have developed, including the fish dryer. Thank you very much, sir. For next presentation, it's my presentation, and I'll be sharing my screen.